Okay guys, first thing I want to do with you is just kind of review a little bit of how you guys would go and find coordinates, so your XY coordinates. Sorry, penmanship is worse than normal, still trying to get used to this tablet. What you would do is you would pick numbers, 2, -1, whatever, and you would take those and you'd fill them in back into the equation. 3 times 2 minus 2, 6 minus 2 is 4. And you'd have your answer. You'd have your ordered pair. You'd have your coordinate 2, 4. And then you'd pick a different number and you'd stick it in and likewise find another set of values for it. So -3 minus 2, I've already done the multiplying, is -5. So you'd have another coordinate, -1, -5. And then you put those 2 points on your graph and you graph them. Now, I'm going to refer back to this in a minute, and there's a couple other things here. Piecewise defined functions. Suppose I should have started off there, I apologize. Get nervous using because I'm being recorded. So here goes. Piecewise defined. You're defining a graph in pieces. So you're not going to be able to use any old numbers that you want. You're going to be only told a certain set of numbers you're going to be allowed to use. And functions, it's just another way to call something y equals. And I'll talk about that here in the next page. You guys, are you comfortable using y is equal to 3x minus 2? Well, the new way of talking about it, or I hate to say it new, but how about a different way of talking about it, is f of x is 3x minus 2. And it's pronounced f of x. And the next thing I said was is, because that's what equal sign is. F of x is 3x minus 2. If this f of x bothers you, you can just think of it as your y equals. It really doesn't act any different. What the f of x does is it does record keeping. So if I write this without the x, it's given me a recipe for whatever I fill in here. This is what I'm supposed to do with it. So if I wanted f of 2, whatever I put here, I'm supposed to put there. 3 times 2 minus 2, f of 2 is 6 minus 2, which is 4. So it reminds you, hey, I filled in a 2 and got a 4 as an answer. It's record keeping. There's no arithmetic, no algebra that's going to happen on the left side. It's just there to keep track for you what you filled in for what you got as an answer. The other thing it can do is it can name a function, f of x and g of x. Rather than saying, hey, take this equation that's y equals and it's got exactly the same name as this one, y equals, and do something with it. Well, I could say take f of x and do this, or take g of x and do that. And again, I'm pronouncing it g of x. This first parenthesis is pronounced of, g of x. Okay? You don't say of again at the end to close the parenthesis. It's just g of x. Okay? To graph a piecewise defined function, like I said, if this f of x is bothering you, think of it as you got y is equal to 2x, and if you want, plus 0. And you've got, let me switch colors so you guys get them color-coded, y is equal to -x plus 3. You've got 2 separate lines. I'll talk about this information in a minute. Okay? But for starters, you just go and you graph those 2 lines. The y-intercept is 0, so you put a dot at 0, and then your slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. Now, pardon me here, because drawing lines with this tablet is really hard for me, so hold on. Okay, so there's one line. Pretty looks like I've been drinking too much coffee, but there you go. And the other, well, before we go to the other one, it says it's only good when x is greater than or equal to 1. Well, this is your x-axis, and here's where it's 1. This line is only good for x values this side of 1 and equal to, but it's only good this side. So this portion over here is no good. Sometimes kids like it if you draw on a boundary. This is the boundary line at x is equal to 1. And this line only lives right of that boundary. So I have to go and erase anything that's not on the correct side of that boundary. This is stuff that's all less than 1. So this line only exists over here. So now let's go and do that one. Y-intercept is 3, so that's right there. Slope is -1, so you go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Again, bear with me here, trying to line up and shoot that line through there. Okay, so here's your line. But once again, I've got it on both sides of the boundary. Here, this is x is less than 1. This side is x is greater than 1. I want strictly less than 1. So I have to go back up and erase this information. And there's your answer. Now, technically, what's going on here is at the end of this one, at this end, I'm supposed to have a closed circle because it has an equal sign with it. And on the end of the other one, I'm supposed to have an open circle on the end of the blue one. But the open circle is filling the closed circle, so it really doesn't matter. Okay? In this particular problem, having an open circle and a closed circle, one just fills the other. Okay? If you guys need to see it again, a little more complicated, y is equal to 3x minus 14. Again, if the f of x business is bothering you. The y-intercept was -14. 1, 2, 3, 4, 5, 6, blah, 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 blah. That goes 13, 14. The slope, I think, was 3, wasn't it? Yep. So up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And so on. 1, 2, 3 over 1. Now the boundary is sitting at 4. So sometimes I really think it's useful. Where did my cursor go? Where is it? There we go. Sometimes I think it's helpful if you guys put that boundary line in first. The boundary line is at 4. So if you go through and put this boundary line in, help visualize for you where the break is between the pieces of the graph. It's not a requirement. It's not actually part of your answer. It doesn't belong in your answer. But this side would be x greater than 4, and this side is x less than 4. So it can visually help you see which side you're supposed to graph. So going back and finishing this line, so I've got this line. Oh my goodness, this one's going to be bad. Come on, you can do it. You can do it. Oh, I blew it. Okay, I don't know why drawing on this tablet is so hard for me, but there you go. It's supposed to be a straight line. That line is only supposed to exist less than or equal to 4. This side, as I drew up above, was the greater than. So this side, oh good, whew, a really bad piece got to come off. Okay? And you're supposed to have a closed circle there at the end. Okay, so life is good so far. Let's come back. How about we switch to red? Now I want to graph this line. The y-intercept is 6. 1, 2, 3, 4, 5, 6. Slope is -2. Sorry, down 2 over 1. 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 Okay? And then let's see how poorly I can draw this one. Whoa! Come on. You can do it. Back over, back over. Oh, this is so hard. I don't know why. Looks like I'm going to have to be practicing with this thing. All right. And then going for the eraser. It's only good greater than or equal to 4. So this side, which was the less than or equal, sorry, greater than 4, this was less than 4. And technically, you're supposed to have an open circle on the end of that red one, but the blue one is filling it. So there you go. The next one is called a step. as in a stair function, step. It's a step function. Okay? It's a special kind of piecewise defined function. If I wrote y is equal to 3, that's a horizontal line at 3. Y is equal to 5, that's another horizontal line, but this time it's at 5. A piece of advice I gave you guys was do your boundaries first. So I'm going to have a boundary at -1. I'm going to have a boundary at 2. I'm going to have another boundary at 4, 2, 3, 4. Another boundary at 9, 5, 6, 7, 8, 9. Another boundary at 12, 10, 11, 12. Okay? Now these boundaries, yeah, I'm being, how about lazy or knowing how poorly my line drawing with this is being, but these boundaries go all the way down. Okay? For this first one, I graphed the line y is equal to 3. So that's going to be a horizontal line segment between -1 and 2. Between -1 and 2. Closed circle on the left, open circle on the right. Because of that, it says don't include it. Then you have a horizontal line at 5. So if this was 3, 4, 5, it starts where this one ended on the boundary and goes to the next boundary. Closed circle, open circle. Again, because closed, open. Next one's at 8. So this was 5, 6, 7, 8. Start here, go between the next two boundaries. This one's closed. This one's open. Go to the next one. Horizontal line at 10. That's 8, 9, 10. And you get a horizontal segment between these two. Closed, open. Okay? And technically, any of those vertical boundaries don't actually belong on the graph. So if you do them, you're welcome to draw them really light and leave it. But if you draw them dark and heavy, you need to get rid of them. Okay? Because they don't actually belong. So that's your entire graph there. Right? I have 2 more graphs on this page, but that's actually ahead of where we need to be. For your homework tonight, you only need to be worrying about stuff that I've showed you so far. So on the bottom of your assignment sheet, that's your homework. Yeah, have a good one. I'm trying to stop this thing. Hold on. Thanks.